Hello guys, today I'm talking about electronic component tester. This unit is transistor tester. You can find it online over eBay or Amazon, like $6-7, and it's working very well. So it's much better than multimeter when I'm going to test the components. For example, I'm using with the choke. I will test with this. After this project, I will exactly show you one by one how to make it with Arduino Uno. It's very simple to do. We check the inductor is detecting very well, and also for a start we should know something. We should make at first the matrix LCD. This is 216 LCD, matrix LCD. It's coming with some pins here and need to solder. Sometimes it's coming with I2C controller like this, and it's connecting to Arduino with 4 wire. But for this project we are going to do the normal one without I2C controller, and it's very simple to make the tester with Arduino like this project. So after finishing this video, exactly you can make this component tester by the Arduino Uno, but you should do the items one by one. So to start, it would be better to download the codes and needed files from my GitHub or any other GitHub, or Google it. I'm not sure that is, but the hex file and the other needed files should be exactly the same, because of the wiring is very sensitive for this project. So I will leave the link for this video to download easy, and I think if you're going to click on the below of the video the GitHub link, you are able to download Transistor test Arduino Uno, and it's coming with some file with five files. One is schematic and the other one is EPROM file and the hex file, and also the AVRDUD, and the application will make upload code very simple and easy. So the first step is opening the schematic like this. This is the file, exactly what we should to do. I will explain exactly. This is Arduino Uno. For this picture, this one is only at Mega IC, but as you see, I'm using the Arduino Uno to make it easier, and this is the LCD and this is the IC socket to test, and this part is push button key, and this is full Arduino project. So after finishing this video, you are able to do your ideas how to fix it with breadboard or some PCB board or any other ideas. So this part is push button circuit. It means when you here is the push button, when you pressing this, the circuit going to be on with a little bit delay, with short delay, and this one is the LED, will show you the device is working, running on or not. This one is the LCD pinout. We will talk about this right now. And this part we are not make it because of going no needed for this one because of for the frequency part. Now we are not talking. So for the LCD I'm going to make it bigger. For this project we need exactly 8 wires. Should be do one by one exactly as I do. I will show you. This is 16 pins. We need pin numbers 16, 15, 14, 13, 12, 11 and pin 1, 2, 3. Pin number 1, 2 and 3 is connected to potentiometer like this. I do. It's very simple. It is very good to adjust the LCD contrast, and also the other wires should be connected from Arduino Uno pin 0 to pin number 5. Just check the colors and look exactly to the picture to solder exactly wires as you checked. I used the jumper wires to do it much better because of this is very sensitive part of the project. After finishing this, the soldering and connecting jumpers to the Arduino Uno from pin 0 to pin 6, going to open the Arduino compiler and going to select from the examples and select liquid crystal, and the sample file is hello world. We are going to select this, and we should change the pin numbers from first one 4, second one 5, next one 0, 1, 2 and 3. So of course we should select the COM port number -13. Maybe you have the 100%, you have different number. So also the board is Arduino Uno, and I'm going to compile and upload the code. Yeah, it's done. So if it was okay, so you should see exactly the hello world code, as you can see. It means that the wiring for this project is pretty well, and we are ready to upload the project code. To do the project code easily, it would be better to running my application I showed you in GitHub. The name is overdud. This is a zip file. Please unzip the file and run the file. So this is the GU graphic based AVRDUD 100%. You know, the AVRDUD is the file. Will upload the hex codes to the compiler. So I'm running the AVRDUD graphical based. This one is. This is easy to select. The COM port is number 13. The baud rate should be 150 to 100. The MCU is Atmega 328, and we are going to use the flash file. And also I have the flash file with the with the GitHub, and also you can download over Google. Also I bring these files all from Google. After this we are going to write down the code. After finishing 100%, the LCD will show something else because of the old codes will be gone. So this is the thing that will show on the LCD. Estimate that is finished, and the Arduino need to calibrate and is ready to use. So we are going to disconnect the USB cable because of with the USB cable noise we are not able to have good calculation. 100% we need battery with battery clip. So after connecting the LCD wires by the pictures and schematic, you should connect analog pin number 0, number 1 and number 2 by some resistors. You need 6 resistors at all. It should be connect from A0, A1, A2 to pin number 8, 9, 10, 11 and 12. You can see by this picture also this is the pinout. This is 3 pieces of 618 ohm and 470 kilo ohm resistors should be connected one by one to the pins that I showed you. And the test pin is number 1, number 2 and 3 is connected to A0, A1 and A2. So the socket green one will exactly connect it to the 3 pins, and the other one is short to each other. The reason of this is maybe you are using the unusual component and it's good space and good enough space to use that one. And after this step, so first step LCD finished, second step is connecting the resistors to analog pins, and the next step is making push button keys. So you need 3 transistors, 1 push button key, 1 regulator IC or transistor, and some capacitors and resistors. I will show you exactly here. For this schematic, the guy used the MCP1702 is very good regulator IC and low usage. Mine will finish the 9-volt battery in couple of hours. It will be better to use this regulator IC if you have it. So the reason that we are using the push button circuit to run this project is the multifunctional menu I will show you in few seconds. This device will work as component tester, frequency generator, frequency scanner, and also the device will going to calibration mode. And also I should say you, after uploading this code, as you see here, the code will write down something on EEPROM part of the Arduino Uno, and it will keep exactly some numbers that these numbers will show exactly the previous and old setup of device. After next running the circuit or running the tester, you 100% will have the old settings and old menu, and the question is where will save the information when we don't have any flash memory or we don't have any space to write down. The answer is the EEPROM inside the IC will keep some bytes dependent to number of the IC, and as you can see here, EEPROM is 1 kilobyte here, and what 1 kilobyte is more than enough to keep the menus information. So after finishing this, I do for the breadboard, and you can do also. The question is, without the push button circuit we are able to use, of course that we are able to do, but it would be better to use with the battery. I said you before, with the battery we have less noise and exact calculation. And also I put one socket here to check the items easy. So this is first analog pin, second one, and the last one is third. So I'm going to plug the battery, and the device is ready to use. After pushing, the menu will come. One by one we can select the menus. The transistor tester, the frequency scanner, the frequency generator going to 3 or 4 megahertz dependent to the configuration, and this is the battery tester. This is the resistor and conductor tester. This one is capacitor tester, and this is self calibration test, will exactly calibrate, and contrast is LED contrast, and also we are able to fix the contrast level by this potentiometer or potentiometer, I'm not sure. So I'm going to switch off the circuit. So to test, I'm going to use the transistor. I'm pushing down this one, and oops, I'm not going to use this now. So I'm going to push the transistor here. It's much better without that green socket we test, because of this short wires. Okay, so I'm going to push and keep a short one, and exactly keep the short one. Is going to test this NPN transistor 338, and this is the voltage. Okay, I'm going to change with capacitor. This one I will open, and again we push the key. Yeah, this is 128 nanofarad capacitor. I'm going to test with LED. This is 1.9 volt, and will show exactly the polarity and direction of the diode. And also I'm going to test with the conductor. Exactly, it will show it's 0.2 microhenry. And for the next level, I'm going to test the frequency scanner and frequency detector. One time pressing the button going to frequency. Next one is frequency generator. I'm pushing and keeping the button for some seconds, and one by one I will select, for example, you can see that I'm going to use it. If I press the line time, I will back to menu, and here is one item for self-test and calibrating device. This item is very useful one, because of we need 100% to calibrate the project. So the show data will show exactly the version of the project, and also the battery level and the resistor situation, so the other items. So we should give it nice thanks for the guy that create this source code to use it. And the last one is switch off the project. Thank you very much, and hope to send me your ideas about this one. Goodbye.